Okay, so today we will be looking at two different titrations. This titration is in your book and it's an example already in your book. And this one is an exam style question that's based on the vinegar experiment. So we'll be taking a look at both of these questions today. If you'd like to take a little read through the question here, maybe even try and give it a go, pause it here and then you can just press play when you're ready to see the solution. Okay, so step one would be to underline the important sections of the question. Here we have 3 grams. I'll give it a different colour. Here we go. 3 grams of an impure sample that was dissolved in water and made up to 250 centimetres cubed. Then 25 centimetres cubed portions of the base was titrated against this molarity of acid, and it's sulfuric acid that we're using. The average titer was 22.9. Here is our important equation for mole ratios of acid and base that's used in the experiment. Now what they're actually asking you to do. Use the given information to calculate the percentage purity of the sample of potassium hydroxide. Now you might think, okay, well I can easily work out the molarity of the potassium hydroxide just by doing the maths around it. So let's just see how we can do that. So usually you would say, okay, let's write all my information about potassium hydroxide there. So we have 3 grams of it and it was diluted in 250 centimetres cubed. Okay. Also, if I work out the relative molecular mass of potassium hydroxide, I'll get 39 plus 16 plus 1. That would give you a number of 56. Okay, so that's the relative molecular mass. Now, if you use the formula, number of moles gives you your mass over your relative molecular mass. You work out the number of moles that you should have there. Okay, 3 over 56 then, if you put that into the calculator, you get 0.054 moles per litre. Now, we didn't make it up into a litre, we actually made it up into 250. So a litre divided by 250 is 4, and it's going to be stronger because it's in a smaller amount of solvent. So it's going to be 4 times the strength, which would give you a molarity of about 0.21 moles. Now that's in a perfect world. We are told that this substance is actually impure. So just remember that little number that we thought, because our answer should be somewhere like that, but it is going to be impure. So I'm just going to rub this all out now. Okay. Now, so let's take a look of how we're going to work out the substance that's impure. We can write down everything that we see for clarity's sake, because usually when we're dealing with titration reactions, we have this equation, molarity of acid times the volume of acid over the number in the acid. Then we also have molarity of the base times the volume of the base over the number that's associated with the base. So let's just check if we've all of those things. So always make your little list on the side. Molarity of the acid we have 0.1 molar. Volume of acid is the average titer, 22.9 centimeters cubed. Number associated with the acid is 1. You can see that from the equation. There's an imaginary 1 there. Molarity of the base, we're not given. We don't know. That's the thing that we need to figure out. Volume of base is 25 centimeters cubed. And the number associated with the base is 2. And we can see that from the equation as well. So we're only missing one variable, so we can go ahead and use this equation. And we're just going to fill it in. So 0.1 times 22.9 over 1. And I'll fill in the rest. And then you work them out and just isolate the molarity of the base. And you should get an answer of 0.183 moles per litre for the base. Okay, so if that's the molarity, then we can go and use the original equation that we had up here a while ago. Number of moles equals, or the molarity equals mass over relative molecular mass. So this one again. Now we have 0.183 mass over 56. We already worked that out previously. Okay, and if you go and work that out to find out what the mass is, by multiplying 56 by 0.183, you would get 10.248 grams per litre. So there's 10.248 grams there. Now we don't have a litre. We only have 250 centimeters cubed. So we're not going to have all of this amount. We're only going to have a quarter of it. So 10.248 divided by 4 to get how much is in the 250 centimeters cubed. And we will work that out to be 2.562 grams of the potassium hydroxide. Okay, and we know that because that's the potassium hydroxide is the substance that is reacting with the actual acid. All of the impurities that are also within the 3 grams are not going to react with it. So when we work out the concentration of the potassium hydroxide, we can then work out based on that how much of the substance is actually within the sample. So you can see that the 2.562 grams is not the full 3 grams. So it's an impure sample. It's not a primary standard, so we need to work out the concentration through our titration work. So then the last question, percentage purity. 2.562 over the 3 grams as a fraction, multiply it by 100 to get a percentage, and you should get 85.4%. Okay, let's take a look at the next one. Again, you can pause, maybe write out what you think is important in the question, and even give it a go. So the first 2 questions are procedural questions. When there's a 15-mark question, you usually know that you should write about 5 points, all at 3 marks each. But you can write a paragraph and just go into detail of what you did to actually make up the solution. The indicator that was used in the acetic acid and sodium hydroxide titration is phenolphthalein. And the colour change is purple to colourless. Always say colourless, never clear. Clear is not an actual colour. Colourless is a colour. Okay, and then we're going to go on to C and D, the mathematical sections of the question. So have a little pause and give it a go. Okay, so let's take a look at the important questions again. We can just highlight them. Now we have to determine the concentration of ethanoic acid in a sample of vinegar. 25 centimeters cubed of vinegar was diluted to 250. So we're taking a concentrated amount of the liquid and diluting it to 250. It was titrated against 1.2 grams of sodium hydroxide in 500 centimeters cubed. That's your average titer. And this is the amount of base that is in our titration. Okay, let's read the question now and underline the important sections of the question. The number of moles of sodium hydroxide in 25 centimeters cubed portion. So it's to do with sodium hydroxide. So let's just look at all of the stuff that we know about our sodium hydroxide. So we've got 1.2 grams and it's diluted in 500 centimeters cubed. Okay, let's go back to our normal formula that we always use. The number of moles equals mass over relative molecular mass. We don't know this number of moles. 1.2, and if you work out on the side, NaOH, you will get 23 plus 16 plus 1, which gives you 40. So the relative molecular mass is 40. Okay, so if you work that out then, you'll work out the number of moles of sodium hydroxide to be 0.03 moles per litre, or you can say 0.03 molar. Okay? Now it's not in a litre, so take a look through, see what it was actually diluted to. 500 centimeters cubed. So that's less than a litre, so it's going to be twice as strong because there is 2 500ths in a litre. So you take the 0.03, multiply it by 2, and you'll get the concentration of the sodium hydroxide to be 0.06 moles per litre. Okay. Now the question asks, how many moles of the sodium hydroxide is in each 25 centimeters cubed portion? So we have how much is in a litre. So next thing, how many 25 centimeters cubed is in a litre? 40. Okay. So if you take that amount of moles that are present in a litre and divide it by 40 to see how much is actually in the 250 centimeters cube portion, you will get 0.015 moles of sodium hydroxide in the 250 centimeter cubed, in the 25 centimeter cube section. So basically each time you fill up your conical flask, you have 0.15 moles of the sodium hydroxide solution. And that's your answer to question 1. Then part 2, we'll wipe this all out. Okay, now the vinegar. We're talking about vinegar this time. And we know something about vinegar. We know that we've 25 centimeters cubed of the concentrated vinegar, and then it was diluted to 250. So we can write vinegar, or CH3COOH. It's also called acetic acid. 25 centimeters cubed of the concentrated one then was diluted to 50 centimeters cubed. Okay, so let's take a look now, because we know in these type of questions we always use this formula if we have enough information. So do we have the molarity of the acid? No, we don't. That's what we need to figure out. The volume of the acid? Yes, we do. The average titer. The number of acid. What's the number in front of CH3COOH in the equation? 1. Molarity of the base, we worked it out originally, 0.06. And the volume of the base, 25. And the number is 1. So if you work out all of that, you'll find the molarity of the acid to be 0.08 moles per litre. Now, that's not what it asked you for. It asked you the number of moles of ethanoic acid per centimetre cubed of diluted vinegar. So we're working with the diluted vinegar here because that is what was used in the titration. Okay, so that's the molarity of the diluted acid. Now, how many centimetres cubed are in a litre? There is 1,000. So you're going to have to take that number of moles, divide it by 1,000 to see how many moles of the vinegar is in only 1 centimetre cubed of solution. So that'll be about 1 mil. So it's going to be really small. And you'll work out 0.00008 moles of vinegar in 1 centimetre cubed. And that's the diluted vinegar. Okay? Alright, so that's that answer done now. D then. So take a look at D, and I'll wipe this out. Okay, again, underline the important one. The concentration of the ethanoic acid in the original vinegar in moles per litre and weight per volume. So it's also a concentration of the original. So let's write down what we actually know. We know the molarity of the diluted vinegar is 0.08 moles per litre. We worked that out already. Also, let's just think about when it was diluted. So we wrote earlier on, and you should have this down as well, that the 25 centimetres cubed of concentrated vinegar was diluted up to 250 centimetres cubed. So the first step to answering these is working out the dilution factor. And you can do that just by dividing the end volume by how much went into it at the start, and you'll get a factor of 10. So it's been diluted basically by a factor of 10. It's 10 times weaker than what it was. Okay, that's important. It's 10 times weaker than what it was. So the 0.08 is the weak one, and originally it was 10 times stronger. So you'll get 0.8 moles per litre for concentrated vinegar. Okay, and that makes sense because 0.8 and 0.08, there's a factor of 10 between them. So that is the first one done, the concentration of ethanoic acid in moles per litre. So I'll wipe that one. And then the very last one is the concentration in terms of weight per volume. That's what WV means. So we worked out the concentration of vinegar, the original one now, is 0.8 moles per litre. Okay, So in weight per volume, you're always talking about 100 centimeters cubed. The weight is usually in grams, the volume is 100 centimeters cubed. So we have currently the concentration in a litre. So how many moles are in 100 centimeters cubed? So 1,000 divided by 100 gives you 10. So that tells you what you need to divide that 0.8 by. And you get 0.08 moles of the vinegar in 100 centimeters cubed. Okay. Now, it's weight per volume, not moles per volume. So we need to convert that number from moles into weight or grams. Back to this equation we always use. Number of moles equals mass over relative molecular mass. And we need to work out the relative molecular mass of vinegar. CH3COOH. So you have a carbon, 3 hydrogens, all at 1 each. Another carbon, oxygen, an oxygen, and a hydrogen. And that gives you 60. So we have 0.08 moles of the acid. Mass we don't know. And the relative molecular mass is 60. So if you work that out, you'll work the mass to be 4.8 grams. So 4.8 grams in 100 centimeter cubed. It's percentage though. And all you have to do, one final step, 4.8% weight per volume. And that's that question done.